Rocky V2 adapter that's both 10 and 25 gig, an Ethernet iWarp adapter, which is 2 ports, that supports both 10 and 25 gig, and a 10 gig iSCSI Ethernet adapter. The fiber channel adapters are both FSP Plus type ports, which they support SFPs, and the Ethernet Rocky V2 and iWarp adapters can support either 10 or 25 gig SFPs, and the Ethernet iSCSI only supports 10 gig SFPs. The SAS adapter is a 12 gig adapter and has 4 ports. It uses a mini SAS HD connection, which are based on direct attach cables and would be used to connect the SAS expansion enclosures to the 5200. We do get questions sometimes about why the 32 gigabit is only 2 ports, and this goes back to the architecture and in the block diagram where the PCI bus going to the adapter is a PCI Gen 3 by 8 configuration, and we try to make sure that we match port performance to PCI bus performance. And in this scenario, a PCI Gen 3 by 8 connection can support the full bandwidth of either 2 32 gigabit ports or 4 16 gigabit ports. And so, at least today, due to that matching, that's the reason why the 32 gigabit port or the 32 gigabit fiber channel adapter is only a 2-port configuration. We do support doing SAS direct attach to hosts as well, but note that when it's a SAS port, all 4 ports can be used when connecting to a host, but when it's a SAS port connecting to a storage expansion enclosure, then only ports 1 and port 3 are used when doing that expansion. One other thing to note is that for the Ethernet connections, even though they specifically denote SFP+, that SFPs for those connections can either be an SFP optical module or a direct attach cable. To show a little bit more on the access to the enclosure fans, here's a mechanical view of the enclosure looking from the front, and there is a fan door that is opened by using these 2 clips on the top of the door. The door will open up towards the rack when the enclosure is pulled out towards the front. This exposes the 6 fans. Each fan is numbered on the fan cover, fan 1 through 6 from left to right. The fan can be removed by using the finger pulls on the fan, and there's also a fan fault LED so that during the service procedure the fan that has failed will have the fault LED lit to know which of the fans to be removed during the service procedure. Once a fan is removed, a new fan can be installed. The fans are keyed such that if you try to put them in backwards, they will not seat correctly and would have to be rotated 180 degrees and then seated properly into the enclosure. They won't even start to be pressed down, so it's easy to tell that the fan is not in the correct orientation. Once the fan is installed, the fan cover is then closed, and then the enclosure is pushed back in the rack and then locked into place with the slam latches. The enclosure has 2 ambient thermal sensors. These thermal sensors are located below drive slot 8 and drive slot 10. They're redundant so that if one has a failure, the other one will continue to operate, and the 2 are used to gather information about the ambient inlet temperature. They are non-concurrently replaceable, and if they do have to be replaced as part of a service procedure, then the system is taken offline. The drive is removed, the fan service door is opened, the fan slot and associated filler is removed, and then the ambient sensor can be replaced. But again, it's a non-concurrent operation. The Flash System 5200 uses the IBM Gen 3 carrier for the 2.5-inch drives. This is a common carrier that's been used in other IBM systems, including the Power Cognitive systems. This is the first time that this carrier has actually been used in a Flash System product. This carrier is different than the current drive carrier that's used on a Flash System 9200 or 7200, as well as the previous generation 5100. They may look similar in design, but we wanted to point out that the carrier is different. We are trying to standardize on this carrier for all of our current and future products, and so future storage or Flash System storage enclosures will use this carrier for the 2.5-inch drives. The Flash System 5200 supports the FCM 2.1, but any earlier version of the FCM, like the FCM1, is not supported in the 5200. The 5200 supports different drive configurations. We want to kind of show an example of how drive configurations are populated in the enclosure. As we mentioned previously, drive numbering and slot numbering of those drives are numbered from left to right, the top slots being 1 through 6 and the bottom slots being slots 7 through 12. When fewer than fully populated number of drives are installed in the enclosure, the drives are always installed starting with the lowest slot number and then populated across the top and populated across the bottom. If the storage class memory drives are used in the configuration, then those drives are populated starting in the highest slot, meaning slot 12, and then populated down. So slot 12, then 11, then 10, and so forth. So in these examples here, a fully populated enclosure would have all 12 slots populated, but if only 4 SSDs were installed, either SSDs or FCMs, then they would only take up the first 4 slots, slots 1 through 4. In the bottom example, there are 8 total SSDs, including potentially FCMs, and in this configuration, there are 2 storage class memory drives. So the initial 8 drives would be populated from left to right, populating the first 8 slots, so all 6 slots across the top and 2 slots on the bottom. And then the storage class memory drives would be installed in slots 12 and 11. So slots 9 and 10 would be empty in this configuration. Any drive slot that isn't populated with a drive must be populated with a drive filler. The Flash System 5200 supports a cable management arm. The cable management arm serves 2 purposes, the first being to help dress the cables as they're connected into the back of the enclosure, and the second is to provide a stop for when the enclosure is pulled out during fan service actions. This makes sure that the enclosure is not pulled out too far on the system during that action, and make sure that the cables are dressed properly when the fans are serviced. There are 2 assemblies, one for the left and one for the right, each one being a mirror of each other. They are installed by connecting a clip to the rail and then a clip to the enclosure on both the left and right sides. Once that is completed, then the cables can be dressed through the cable management assembly and connected to the enclosure. When a canister needs to be serviced, one side of the cable management can be removed to service the canister or power supply in the back of the enclosure, and then once that service is complete, the cable management arm can be reinstalled using the clips on the rail and the enclosure. The battery is designed based on a previous battery architecture that we've been using for a number of years. We're working on standardizing the battery interface so that future products can reuse the battery design such that the software interface, firmware programming interfaces, and overall architecture are similar generation to generation.